Okay, now what if you have a situation, let's just say, for example, you're given 1 point and you're given the slope. Well, actually, you could even think about how you might calculate the slope. So let's say I wanted to find the line between the points, I don't know, let's make them up, 7, 5, and 14, 0. Okay? Does anybody remember how you would actually find a line between 2 points? Like neither one of these points is the y-intercept. How do you know that neither point is the y-intercept? Neither one of them has an x equal to 0. So whenever you see x equals 0 in any point, you guys, that point will be on the y-axis. Do you know anything about any one of these points where they might be located? There's a 0 here. Is this point on the y-axis? No, this point is on the x-axis. So if you wanted to find, let's say, the slope, m equals y2 minus y1 over x2 minus x1. Has anyone ever seen this equation before? This is the equation for the slope. So here we could just call this the first point, x1, y1. This is second point, x2, y2. And then if we wanted to calculate the slope, we could plug these numbers in. So tell me what to plug in. 0 minus 5 over 14 minus 7. And then what do we get? Negative 5 over positive 7. Okay, well, I know the slope, but I don't know the y-intercept. Okay, so that was just a little example of how we could calculate the slope. By the way, I don't have the equation of the line yet, though. So that brings us back to this form. We call this form right here the point slope form. Y equals m times x minus x1 plus y1, where m is the slope and x1, y1 is a point on the line. So if I wanted to turn this in to the point slope form, I would just go y equals my m I just calculated, and then I have x minus, I can use any point. I could use this one or I could use this one. Doesn't matter which one. But I would go minus 7 plus 5. Does everybody see where I got that? Because I'm plugging into my formula the x and the y. Now, of course, I could rearrange this and then put it into slope y-intercept form. If I wanted to do that, I could distribute the slope and I get equals negative 5/7 x. What's negative 5/7 times negative 7? Yeah, what's the sign? Positive 5 and plus 5. So I get y equals negative 5/7 x plus 10. How convenient that that worked out, okay? So that would be my y-intercept would be 0, 10. And I just got that by using the point slope form. So the idea here is if I wanted to graph that line, I could use the point and then use the slope from there. So we have a couple of different, in this chart here, we have a couple of different examples of problems that are actually just written in the point slope form. And just looking at the equation, can we identify what the slope is? So this example says if I have y equals 2 times x plus 3 minus 4, this is not in slope y-intercept form, this is in point slope form. The slope is 2, and where are they getting this point, negative 3, negative 4? Do you see from the equation where it comes from? It's going to be the opposite of the sign of the x and keep the y the same. So you're getting a negative 3 and then negative 4. So let's look at the next one. What's the slope of this equation? Negative 3 over 4. And what's the point? Positive 5 and 8. Great. Okay, let's do the next one. What's the slope there? -7's the slope. What's the point? Yes. And what about the next one? Yes? And -4, -5, or -9, -4. Yeah. Do you see where I'm getting these answers from? Great. Yes, so that's going to be once you have a problem written like this, if you can identify that that's the point slope form, you can take the slope and then you can find that point just by looking at that form written that way. Okay? And so just like we did before, if I wanted to graph a problem that's in point slope form, I would take the point and the slope. So go ahead and tell me here, what's the slope? M equals 2/3, and what's the point? -1, -2, and that's going to be the trickiest thing to remember, is just to change that sign of the x there to that. Okay, then let's go ahead and draw our x and y axis and scale it. So we have our y axis, our x axis, and if I want to put a scale, I'm just going to use a scale of 1, 2, 3, 4, 5. Maybe I count here 2, 4, -2, -4. Am I still using a scale of 1 on the x-axis even though I counted by 2's? I am, because I just left that blank, but there's an implied 1, right, in between 0 and 2. Here I could go -2, -4. I'm just showing you some little strategies on how you might save a little space and time there, but still using a scale of 1. Okay, now if I go ahead and plot this point, -1, -2, I go over to -1, down to -2. There's my point. Instead of putting the point on the y-axis, because I don't have the y-intercept, I'm just going to start with this point, -1, -2, and then I can use the slope from there. So how do I use the slope? My slope is my rise. Yes, so I'm going to go up 2 over 1, 2, 3. Up 2, rise 2, 1, 2, run 1, 2, 3. How could I get a point down here? Because there's a line here, but I want another point. I would go down. This is the same thing as -2 over -3. I go down 2, rise -2, run 1, 2, 3, -3. And those points are all collinear because they're on the same line. So this is the equation y equals 2/3 x plus 1 minus 2. Here, it's nice that we had the point slope form, because if you had solved for b, if you had distributed, you see that your y-intercept is crossing at a fraction, right? Any questions about that? Okay, before we do the next one together, I want you to try that one, and then we'll go over it.